Hi, ladies and gentlemen. This is Mr. Green. I'm a teacher in the. Oh, wow. Jumping into my normal phone call messages. I just wanted to let you know this is a continuation of my Algebra 2 lessons. I wanted to make certain that we get all these topics covered for sequences and series. So we're going to keep rolling on that. Now, what we're going to do today is we're going to do a little bit of work trying to determine whether sequences and series are either geometric or arithmetic or neither. Okay? So we're going to look at them. We're trying to make certain if they're geometric or if they're arithmetic. Remember, arithmetic sequences have a common difference, D. And a geometric sequence has a common ratio, R. That's the way we will tell them apart. I've written the formulas for finding the sums in here, and we can use those in just a couple minutes. So looking at these, how do you determine if it's geometric or if it's arithmetic? Well, the first thing I do is I always try the arithmetic one because it's easier for me. So I take 12 minus 4 and I get 8. And I take 36 minus 12 and I don't get 8. I get 24. So it is not arithmetic. That's not going to work. So I try geometric. Let's see here. This has got to be a 3 times 3. And then I go from 12 to 36 times. Yes, it's working out. Times 3. So this one is a geometric. Okay? So let's come over here and look at the second one. 2 minus 1, I added 1. 6 minus 2, I'm adding 4. Nope. Still not an arithmetic sequence. Okay? Let's see here. If I multiply by 2, I get times 2. If I multiply times 2, I get 4. I don't get 6. Wow. Doesn't look like it's either one of those, is it? So I would call this one neither. It is neither. Neither. It is not arithmetic and it's not geometric. Okay? So let's look at a couple of applications because this isn't just done for the pure pleasure of mathematics. There's actually some applications behind this. This one is kind of contrived, but an application nonetheless. Okay? It says Brian and Kayla try different methods of saving money. Determine the total amount of money each will have after 10 days. So what's my n going to be? In both cases, n is going to be 10. We know that. Who ends up saving more money? So let's see here. In A, what do we got here? We've got an A sub 1 of 51 cents. And we've got a common difference of 0.01. How did I get that? Well, I looked at day 2. I subtracted that, and I see that it's growing by 1 cent every day. Okay, don't remember the formula, so let's back up here real quickly. Arithmetic sequence, n over 2 divided or times a sub 1 plus a sub n. Right? So let's come here. Do we know that? Well, we can figure out what it is on day sub 10. They will have added 10 cents onto it, so it'll be, oh, hang on a second. Okay, well, we don't know a sub n, do we? So let's use the formula n over 2 times a sub 1 minus a sub n. Is it a sub n? It is. It's n minus 1 times d. Okay? Let's plug these values in real quickly here. We're going to have 5 times 51 times 2 is $1.02, 1.02, minus n minus 1 would be 9 times 0.01. That's a times. So that's 5 times 1.02 minus 0.09. Let's see here. That'd be, let's see, if we subtract 10 cents from it, we get 92, so it'd be 93. So it's 5 times 93.93. And what we're going to get when we do that is 4.65. $4.65. So let's look at B. Do we know A sub n in this situation? Do we need A sub n in this situation? Let's go back and look at our formula. No. All we got to know is that R, right? Well, our R, we knew what that value was. So we shouldn't have any problems with that. Screen's flipping out on me here. Okay. So what are we going to do here? We're going to take A sub 1 times R to the nth power. Okay? So that is A sub 1 is 0.01 times 1 minus, and it's multiplying times 2, 1 minus 2 to the 10th power divided by 1 minus 2. Okay? Well, 2 to the 10th power, it shouldn't be that difficult. 2 raised to the 10th power gives me 1,024. So 1 minus 1024 equals that number times 0.01 gives me that number divided by -2, -1 gives me $10.23. So over here I get $10.23. So, who winds up saving the most money? Is it Brian or Kayla? It's Kayla. She saves $10.23 where Brian only saves $4.65. Cool? Okay, let's look at another quick example here. Suppose an auditorium has 30 rows of seats. There are 30 seats in the first row, 32 in the second row, 34 in the third row, and so on. How many seats are in 30 rows? Well, once again, I see an arithmetic sequence. How do I see as arithmetic? Because my common difference is 2 every time. 2 in every successive row. Right? And so what are we going to do? We're going to take n over 2, because we're trying to find the 30th sum, right? N over 2 times 2 times A sub 1 minus n minus 1 times D. Okay? So we can plug values in for all of these. 30 over 2 times, well, A sub 1 is 30, so that number there is a 60, minus, and this one is 29 times 2. Well, 29 times 2 is 58? 68? 58. So 60 minus 58 is 60 minus 58 is 2. And so I'm going to have, oops, must be missing something in my formula. Hang on. What am I missing in my formula? D is equal to a 2. And is it, it's minus? No, it's plus. That's what I'm doing wrong. Plus. Do that wrong every time sometimes. So 60 plus 58 is 120 minus 2 is 118 times 15. So I got 15 times 118. Let's see here. 15 times 118 is equal to 1,770. So the auditorium has 1,770 seats. Okay. Okay. After you work a few problems in the book, I think this will become a little bit clearer for you. If you're not, please get in touch with me. Ask questions. Let's make certain we understand what's going on. I look forward to talking to you next time as we continue these lessons.